I think we're ready to start. Just checking with the producer, Tom. Are we good to go? Just looking in the chat session here.
Tim, we're good to go. Can you hear me?
Good to go. I can hear you. Yes, I can hear you fine. Thank you. Okay. Good morning, everybody. My name is Tim Cox, and I manage communications here at Bruvity. Thank you for taking time out of your day to spend it with us. We've got a technically interesting and we hope educational webinar planned for you. Our focus of today's webinar is how to apply artificial intelligence and machine learning in service organizations. Whether you're a consumer appliance manufacturer, a commercial appliance manufacturer, or a warranty company, of course, you're looking to improve the level of service you offer while containing costs. We'll be covering the basics of artificial intelligence, which we'll sometimes call AI, and machine learning, which we'll sometimes call ML. We'll define these core concepts, describe how a machine learning model is built and trained, and then show how these technologies are applied in real-life consumer appliance service scenarios. Before we start, please note that the chat channel is open for your questions throughout the presentation, so feel free to shoot questions in as we go. However, we'll respond to those questions during the Q&A at the end of the webinar. Now, let's see. Oh, I'm trying to get the next slide. Excuse me. There we go. So with me today are two gentlemen who represent both sides of the equation, both the business side and the technical side. On the one hand, Tom Meehan works closely with Bruvity's home appliance OEMs, as well as our home warranty and extended warranty customers. And meanwhile, Ajay Walavalkar heads up our data science organization. We're going to get started by setting the scene for today's business environment. And for that, I'm turning things over to Tom. Good morning, Tom.
Yes, good morning, Tim. Yeah, let me do some, setup here. AI technologies continue to evolve and are getting more widely deployed across a range of solutions and industries. Home appliance manufacturers and the companies that provide service contract for this type of equipment, such as home warranty companies and extended warranty companies, are looking for solutions that will reduce their expenses, improve their customer experience count, and with that, increase the likelihood of further equipment purchase or service contract renewal. But they're doing these two things by introducing technology that improves first-time fixes. At the call center, or if a truck has to be rolled with a service technician, looking to ensure that there are no repeat truck rolls. And they want to provide tools for self-service also. And this is, I think, a continuing growth path in terms of how people interact with their service provider. We're going to see more of this with a younger demographic preferring this type of engagement. They're also going to need to function in this COVID-19 era where remote triage and fixes and intelligent service dispatch have to be delivered. So we will talk today about applying AI to achieve these solutions and objectives. And this is really where Bruvity comes in. I talk to a lot of customers, and often when we talk to home appliance OEMs and home and extended warranty companies about AI, the first thing they often ask is, how do I apply AI to my service ecosystem and workflows? Where do I start? What do I have to do? And this is essentially the essence of what we're going to talk about today, with Ajay giving a brief primer on AI and ML, then applying that to home service. And then I will talk about AI-enabled customer service applications and features that Bruvity has for the home service appliance ecosystem. So I'm going to hand over to Ajay now, who's going to start with an introduction to AI ML, and then start to apply it to the home appliance service ecosystem. Ajay?
All right. Thanks, Tom. So as Tom mentioned, These days, AI, ML have become very popular terms. With the explosion of data and increase in computing power that is available, it has now become possible to use these technologies for real life problems. But before we dive into how these can be used in the appliance service industry, let me quickly describe what is AI, what is ML, how they are related to the traditional software programming that we are used to till now. So if you look at AI or artificial intelligence, it is a wide term encompassing any technology that helps create computers that can reason. So from that definition, even a calculator can be seen as an artificially intelligent device with a limited intelligence. Various methods such as logic, rules, decision trees are also part of AI. Machine learning is a subset of overall AI technologies, and it is becoming more and more popular these days. So let's understand what is machine learning. So machine learning is basically a set of computer algorithms that can learn from the data without any rules being specified on how to or what to learn. That is the main important part, that you don't need to specify rules for this. Most of these techniques that form AI have existed in the domain of statistics for many decades. But like I said earlier, we now have huge amounts of data available and cheap computing power to process this vast amount of data. So what has mainly caught on now is a subset of ML algorithms called deep learning algorithms. These deep learning algorithms such as artificial neural networks, these can learn from huge amounts of data. And these are the ones that are catching most of the attention these days. So let me go back. And so now let's look at how AI or how machine learning is different from the traditional programming. So in the machine learning, we saw that we don't need to specify rules. In the traditional programming, what we have is we have rules that are programmed in. So we have humans or programmers who provide rules or programs or instructions on how exactly to process some incoming data and arrive at the answers. So for example, we can write a program which can take in all the data of incomes and expenses during a year and calculate what are the tax liabilities for a company or a person. In order to do that, we need to know what are the exact tax rules, and then we need to code those in, we need to program those in. That's how the traditional programming has worked thus far, right? So if you look at machine learning, that's slightly different. In machine learning, we don't provide the rules, but we provide the data and the answers, right? So now let's look at a problem which is slightly different from the tax problem. Let's say we have a problem, we want to write a program that can differentiate a picture of a flower from a picture of a fruit. How would we do that? We don't know any rules on how this differentiation can be programmed in. So we cannot use the traditional programming methods. So we think, how have we learned this as children? We are not taught these rules on how to differentiate a fruit from a flower, but we are shown several pictures of fruits and flowers, or we know a fruit from a flower, and we learn to differentiate the patterns between these two objects. So when we look at machine learning algorithms do exactly the same thing. So to train a machine learning algorithm, we provide many pictures of fruits and flowers and their answers or labels telling each picture whether it's a fruit or a flower. Now the machine learning algorithm learns the rules on how to distinguish between the two. And when it is presented with an image that it has not seen thus far, it applies those rules and comes out with a label of either a fruit or a flower. So that's the main difference between the traditional programming and machine learning. Now that we understand the fundamental difference between traditional programming and machine learning, we can look at the steps that are taken in the process of building a machine learning model. So there are 7 steps that go into building a machine learning model. As we saw, the basis of machine learning model starts with data. Data is an essential ingredient of any machine learning model. So gathering the data is obviously the first step of the model. But most of the times, the data that is obtained or that data that is gathered will contain a lot of unnecessary details, a lot of inaccuracies, and will need a lot of processing to extract data features that are meaningful for the model that we want to build. This is a very crucial step in the process, and it usually takes a lot of time and effort to ensure that it leads to a better performing model. Eventually, it is the quantity and quality of the data that decides how good a model we are able to build. Available data is usually split in 2 parts. A large chunk of data is used for training the model, and a small chunk of data is kept aside for evaluating the model. In the next step, we need to choose the appropriate algorithm from a wide variety of algorithms that are available. The objective of the model, why are we building this model? What is the function of this model? What type of data do we have available? What is the quantity of the data that is available? All these factors will influence the choice of the model that we select in this step. If the quantity of the data is sufficiently large, we can select a deep learning model such as one of the neural networks. If not, then we go for the shallow learning models. In the next step, we use this process data in the step 2 to train the algorithm and build a model. During this training process, the tunable parameters of the algorithm are adjusted such that the model is fitted to the data available. This is similar to fitting a curve through a set of points and obtaining the equation of the curve, but in a much higher dimensional space. So a typical neural network model can have thousands of tunable parameters, and the entire training process and tuning of the parameters is more or less an automated process. So once a training is completed, now we have what is called a machine learning model. So we take the algorithm and turn it into a model once it has gone through the training using the data that we have. Once we have this model, now the next step involves finding out how good is our model. That's the evaluation. So we need to have, based on what the model purpose of the model is, we need to have a evaluation criteria or evaluation metric. And we need to then use the smaller chunk of data that we had kept aside for model evaluation to use on the trained model to see how well is the model able to perform. If the model is performing with sufficient performance metric, then we are done. We can deploy this model and start using it in production. But that rarely ever happens. Mostly we have to perform the next steps, which are hyperparameter tuning and check again the evaluation. So basically steps 4, 5, 6, we go through them in iterative manner multiple times before we have a performance evaluation metric that is in the satisfactory range. And that once that is achieved, that's when we say the model is ready for production and it starts predicting the results for in the production setting for totally unknown data. So this this process of building machine learning models can be used for data of various types. It can be used for images like we talked earlier, classifying a fruit picture from a flower picture. It can be used to understand text written in natural language, as can be found in various CRM systems that are logging customer support interactions, or any other type of data that can be available. So now let's look at some common examples of different machine learning models using variety of such data types. So as we saw, a machine learning model can be used which can take inputs as images, and it can be used to make various classifications. For example, we can have a model that can recognize the extent of physical damage to an appliance based on the picture of a damaged appliance and it can decide whether the appliance is now worth servicing or it makes sense to replace it altogether. Those kind of decisions can be obtained from the model. Just like an image, a speech can also form part of the input data for the model. So understanding of human speech signal is very important. It can be used, say for example, in IVR that can respond to consumers calling in. This can reduce the load on the human agents. Here, what is needed is not just understanding that an input audio signal is a human speech signal, but also the language model is required to understand the speech. So the language model is needed to understand, for example, English or different languages. But the language model can also be used then to understand typed or printed or written text, which is also in a natural language. So natural language, understanding of natural language is called a natural language processing or NLP. And this can be spoken language, this can be written text. The understanding of intent of the sentences requires more than just simply understanding the meaning of each word, but you need to understand the context and a lot of other things. So we'll look at the NLP or natural language processing a little bit more detail in the next slide. But continuing on, various different data sources that can be fed into machine learning models. We can also have an audio signal, which is not a speech signal, but a signal, let's say, coming as a, let's say noise from a refrigerator. And we can build a model which can classify this incoming noise as, a jammed auger in the ice dispenser versus maybe a faulty compressor. Where is what is going wrong with the appliance? So these kind of models can be built. However, data needed to build such models is not easily available. So that's one of the sort of limiting factors on how good these models can be. Just like audio signal, a video signal can also be used as input for the machine learning model. A machine learning model can be used to do video analytics. A video recording of an installation process of an appliance can be analyzed and see whether any of the crucial steps have been missed or something like that. So these kind of models can be built. In addition to these common sort of data inputs, these days we see a lot of sensors being embedded in appliances, in the smart appliances. So there could be vibration sensors, there could be temperature sensors. A lot of sensors are there in the connected appliances these days. And the data streaming from these sensors can be used to build variety of models that can predict maybe faults before they develop. And a lot of these applications may sound far off in future, but they are not, because the sensors are becoming very ubiquitous these days. And this is something that is coming very fast. So though I said that in the audio section, there may not be enough data available, etc., but there is enough data available in public domain to build very useful and usable natural language processing based applications. These applications end up bringing a lot of efficiency gains for the appliance service industry. In the appliance service domain, one of the main workhorse machine learning model is the NLP model. So in the next slide, we'll quickly look at what are different parts of NLP model and how they are used to understand the natural language. So in the appliance service domain, there is a lot of text data available in the open source, such as appliance use and care manual, frequently asked questions, service bulletins, discussion boards or discussion forums on appliance repairs and things like that. So all these data can be processed using natural language processing engines. There is also a lot of data available with various OEMs and appliance customer support operation organizations. That data is proprietary, that belongs to each of those organizations. In order to use this data to troubleshoot customer complaints or help servicers with analysis of faults and deciding the exact parts needed to fix the complaint, it is necessary to leverage the state of the art in natural language processing. So natural language processing has at its core a language model. Okay, so natural language processing is broadly a manipulation of human language, human natural language by computers. So it is a combination of linguistics, computer science, and machine learning. Language model, like I said, is the central part of that process. So the natural language model exploits a technology in machine learning that is called transfer learning. So what we want to do is, first, we want a basic English language model that understands the construct of the sentences, the verb, the nouns, those kind of things, their relationships. So it is able to identify noun phrases, verb phrases, and meanings of most of the commonly used words. This model can be developed by training it on a huge text corpus, such as all of Wikipedia of 2.5 billion words or something like that. And then we have a basic English language model. Now this English language model will need to be fine-tuned further. So we take this trained model and train it further or fine-tune it further using the corpus that is specifically appliance related. So the manuals, etc., that I described earlier, we train the model using that. So this helps the language model learn industry-specific terms, their context. Use of common English words is already there, but the use of common English words in industry context can be learned. So we have performed this exercise at Bruvity and developed our base appliance language model. We can then use proprietary data if it's there to fine tune it further to capture the knowledge from an organization which has its own knowledge corpus or database of knowledge. So the language model consists of different components. First component is a lexical analysis that involves identifying and analyzing the structure of words, collection of words and phrases in a language. So lexical analysis is dividing the whole chunk of text into paragraphs, sentences, and words. Then comes the syntactic analysis, which involves analysis of words in the sentence for grammar and rearranging words in a manner that shows the relationship among those words. Then we go to the semantic analysis that consists of deriving the meaning from a sentence, using not only the words in them and their interrelationship, but also using the context in which they appear. Just as in case of human understanding of language, it is not a deterministic process, but a probabilistic process, where multiple meanings can be possible with variety of probability values attached to various meanings, and then we select the one that looks the most probable meaning in a given context for the given sentence or given text. So the input to the model is a sentence or a paragraph or a natural language text, and the output can be either an understanding that this problem is related to a refrigerator, a leak, or something like that, or the output can be, okay, this is a question asked and there is an answer in this manual or database, and here is the answer. So depending on what the output is, the output transformation takes care of that to decide what is the intent and what should be the output of this. So that's in whole is a natural language processing model. So the natural language not only learns from database corpus of manuals, FAQs, but also interacts with the corpus to understand the intent of the text and delivers the output that is required. NLP technology forms core of many of the tools that Bruvity has developed for appliance service industry. So in the next slide, we'll take a look at some of these tools that Bruvity has developed, which are based on ML technology and specifically targeting the appliance service centers. So one of the key pieces of application that we have is a chatbot, which is based on NLP technology. So the main focus of our tools is on troubleshooting consumer issues with the appliance. A chatbot that can be used either by a a customer support agent or a consumer. This is forming the core channel through which the troubleshooting help is provided. The chatbot provides access to troubleshooting decision trees using plain natural English text. The chatbot is also a gateway through which access to knowledge corpus is provided via smart search. The context of the conversation obtained from the chatbot is used to search through the corpus using NLP-based smart search engine that we have developed. This ensures highly targeted search within large document corpus where not only relevant documents are identified, but the exact paragraphs where the relevant answer to the question is, these are extracted and presented to the user. So this is a very efficient way of answering or troubleshooting an appliance problem from the consumer side or for the customer support agent. So in addition to aiding troubleshooting of appliance issues, once it is established that the technician's visit is needed to resolve the appliance issue, the troubleshooting has not addressed the problem, our tools can predict the exact parts that are needed to be carried by the technician to service this appliance. This improves the user experience. This improves the cost of servicing as well. And many times we are seeing that the consumers do not know the appliance model or service or the serial numbers to even get started with their troubleshooting calls. So we have an ML-based model, which is a image processing model, image analytics model, which is helpful in improving this user experience such that the user can take a picture of the rating plate of the appliance, and the model will and the machine learning algorithm will extract the model number and the serial number and populate it for the consumer. So these type of models we have developed, and these are very useful. So the ML technology, machine learning technology, can be used to improve effectiveness of customer support agents, increase the ease of troubleshooting, and generally improve user experience of the consumer with the appliance customer support. This data can be combination of public data along with support organizations' proprietary data. I think that is the ML overview that I wanted to discuss here.
Thank you, Tom. Ajay. Yeah, over to you, Tom. Do you need me to advance the slide for you?
No, so let me look to grab control, Tim.
Okay, yeah.
Make sure I can get to the next slide.
Here we go. Handing it over to you, Tom.
Okay. Okay. That my double click became a triple click there, I think. So, okay. So I'm going to walk through some Buviti customer service applications and features that would be used by a customer service organization. Okay, and we're going to provide a demo as well. These directly leverage the ML models and technology that Ajay was talking through, okay, including the chatbot, smart search, parts prediction, octable character recognition, and use natural language processing as well. These applications and features are used across the entire service ecosystem. Applications and features for the call center agent, for the field service technician, and for the end customer itself, okay? The virtual assistant app is primarily used by the call center agent, and this will include an AI-driven chatbot that allows an agent to triage and fix problems, and then using smart search that also provides contextual information from manuals, facts, and videos that are directly related to the actual problem and piece of equipment that is being triaged and troubleshoots. And I'll give a demo of this shortly. Customer self-service is used by the customer to, just bear with me one second, is used by the customer to resolve problems. It also features an AI-driven chatbot and other contextual information about the particular problem that the customer is trying to resolve. The AI optimized decision tree allows the call center agent or customer to triage and fix a problem by a chatbot, and you'll see this in the demo. And equipment identification, we have optical character recognition capabilities that allows for a picture to be taken of the rate plate, the model type and serial number to be identified, and for that to be populated back to the call center agent to allow them to continuing the triage for that particular model type and serial number. And often, finding the model number, the serial number is a very time-consuming process that customer server agents have to go through. This capability allows us to read the rate plate and automatically populate the apps that the call center agent is using. So I'm going to move on next with a demo of the virtual assistant. Okay.
Yep, good.
Okay, let me go one back. So this is the first screen. So this app will be used by a call center agent typically. Okay, this initial screen, populates with information around the service record itself, the manufacturer type, the appliance type, initial categorization, and of the problem and the problem type. Okay. That is the beginning of the decision tree that the call center agent will use to triage the problem. Okay, so I'm going to begin to populate these out here now. There's a service record already associated with this when the call was made. We're going to select an option for the particular type of equipment that's being triaged. This version of the software has models available for ML models available for a range of equipment product from GE Appliances and from Samsung. Okay, I'm going to select GE Appliances in this case. The appliance type in this case is a laundry equipment. The problem category is around noise, and the problem type is kind of further defined around unsettling noise that's coming from the laundry machine. Then the model number and the serial number are populated. And then we begin by launching the virtual assistant. Now, in typical operation, there is often an integrated with a CRM that the end customer may have. So a lot of that information here will actually auto-populate, including the model number, the serial number, the service record number, and the type of equipment it is. As I mentioned in the previous slide, we have OCR capabilities, optical character recognition capabilities that can read a rate plate. And when they're used, they'll auto-populate the model number and the serial number into this screen. So call center agents now begins with launching the virtual assistant. And this is the screen they have, which has multiple components. One of the core ones is over here on the bottom right, okay, or the extended bottom right. This is the chatbot, okay? And this is the interaction the call server agent will have, okay, to try and triage this problem, okay? So this virtual assistant is already populated with some initial understanding of how the problem was categorized and initially described. And it begins the triage process using this information. So all of the other components of this screen are directly contextual to this piece of equipment, in this case, this GE laundry of a particular model type and its associated serial number. So the facts, the manuals, the videos are all directly contextual to this piece of equipment and to the problem at hand, okay? We're also able to look at service records that may be associated with this particular model and this particular serial number, okay? And there's visualization of the appliance info itself here up in the top right. So the chatbot is using an AI-powered decision tree to help triage and troubleshoot the problems. We're using smart search capabilities, that is, search that's contextual to home appliance language and information, okay, to find the relevant selections of facts, manuals, videos that are directly contextual to this model type, okay, this particular serial number of that type of model, okay, and the problem that's been defined to date, okay. So if I advance here in the chatbot, the chatbot is giving more options to the customer service agent to further define what the problem is, okay, in terms of the type of noise, okay. It'll give you some suggestions for answers in this thing, but you could also enter free text here down in this section here to further define, in this case, what the noise may be, okay. Or if some of these initial suggestions from a categorization point of view don't satisfy. So the natural language processing technology that Ajay was talking about, directly utilized by this chatbot, and we, if we chose to in this case, could enter free text here that defines the problem more or defines it slightly differently than what is being prompted here, okay? And that will go into the decision tree and come back with a next stage of recommendation on the problem. Okay, so based on the the selection of the vibration, shaking, banging description of the particular noise, okay, the chatbot comes back with a potential solution, okay, for this, and if I can expand, if I want to expand this out, it's actually recommending leveling the top load washer to rectify this problem. I can just expand out that out for a more detailed description of what is recommending the solution to be, okay? So if you remember, we had a noise issue and with some vibration. The recommended solution here that the chatbot is suggesting is around leveling that, okay? And then there's a series of other contextual information that the agent will have where it can get a visualization of the exact device type that's being in use, okay? It can look at frequently asked questions about this particular problem, okay? And one of those came up right there. And then this would be directly related to the problem, the model type, the serial number there. Similarly, you can look from at an excerpt from a manual, okay, to talk to this particular problem for this particular model type. That is the section of the model that's relevant for that. Or it can search for videos that are directly related to this problem, okay, and the suggested rectification for this problem. So in this case, it's found a video that will show you how to level a top load washer, okay, and if needed, that video can be sent directly on to the end customer to help them to troubleshoot the problem. Okay. Clicking too fast there, it's a little slow in response point of view. So the chatbot will come back whether this selected solution rectification solved the problem. In this case, yes. So we have the call center agent using the chatbot and the decision tree within the chatbot, okay, was able to triage the problem, identify a proposed solution, okay, had the assistance of contextual facts, manuals, videos, okay, to be able to illustrate more clearly how to resolve the problem. And in this case, the agent was able to solve the problem for the calling in customer. And again, for reporting purposes and for feedback loop purposes into the AI engine, okay, we recorded in this case that this was a successfully saved call, and the agent was able to resolve the problem in conjunction with working with the end customer. So it creates an associated record associated with this call. Captures the associated feedback in terms of what was most useful in troubleshooting the problems. Okay. And then we resolve the problem, we can end this chat session. So in this case, this information that is sort of being used associated with this call is used for several purposes. You know, we have a management dashboard that will show the performance of this tool, okay, and individual agents, okay, in solving and addressing problems. And this will be recorded within that management tool. But there's also a feedback loop that goes into the machine learning models, okay, that further trains and learns those models based on this individual experience, what the problem was, what the resolution was. And that's then used to train the model and helps with making further predictions to call server agents using these tools. And then we would go back, that one was finished with and rectified, and we go on back to the next call that the agent would take. Okay. So I'm just going to talk about a case study that uses these tools. One things that we didn't kind of look at in the call center agent virtual assistant tool, you know, it includes capabilities and attributes that if we can't resolve the problem over the phone, okay, and a dispatch has to be made, okay, there's an interaction that occurs between the virtual assistant call center tool, okay, and a field service technician, okay, where it's providing the most accurate information assessment about what the problem is, okay, and that information is fed to the field service technicians so they're better armed and prepared to know what the problem is and what the likely initial resolution of the problem is when they go out there. There's also a parts prediction capability, okay, where our AI engines, based on the model, based on the problem, will make a prediction of what parts are most likely needed, okay? And that information is again fed into the field service technician and that ecosystem. And you can schedule the call and determine who goes on the call based on part availability and whether that particular either, you know, employed contractor, or if you're using a third-party service contractor, has that appropriate part. So the field service technician is armed with the right parts for the job, okay, but also the right information that's coming out of the interaction with the call service agent and virtual assistant to be able to resolve the problem once they go on site. Okay, so this is a case study from a customer of ours that uses this technology, okay, in their extended service ecosystem, okay? And I just want to talk to some of the results we've seen in this particular deployment, okay? So this first time complete measurement is a measurement of whether a call center agent who receives a call that is about, you know, troubleshooting a particular problem and issue, okay? The percentage of times they were actually able to rectify the issue with a first call, within the first call, okay? Before using Brevity technology and then after using Brevity technology, okay? So this went from, and this is again measuring the ability of the call center agent to resolve a problem where a customer has an issue in the first call, that went from 22% to 39%. So a 77% increase, okay? Around truck roll reduction, the process in this particular environment is that if they have an issue, okay, end customers can schedule service online, okay? They then get a call back from a call center agent who tries and resolve the problem without actually having to do a truck roll, okay? And this is so-called save rate. And then the before number, before Brevity technology, was at 23%. That is when they call back, they were able to avoid a truck roll 23% of the time. So that went to 36% with Brevity technology, which really is a truck roll reduction of in the order of 57%, you know, and that is obviously a big saver from a financial perspective. And a big increase, I think, in terms of a before and after from Brevity technology. This particular customer also introduced self-service, okay? And just from comparison purposes, you know, their prior self-service technology was relatively rudimentary. We introduced into their self-service an AI-enabled chatbot, okay, with, you know, very similar features to the chatbot you saw in the virtual assistant demo, okay? The success rate of the customer being satisfied by the self-service interaction went from 15 to 53%, okay? Which is really, you know, a 300% increase in performance. But, you know, we were doing this, you know, I mean, from comparison purposes, you know, their prior self-service technology didn't have this intelligence and AI-enabled chatbot capabilities. But I think, one, we're seeing a big increase in obviously satisfaction performance, okay, by the introduction of this technology for the end customer. But I think there's real attributes in self-service in one, you know, call deflection, okay, in the fact that they don't have to call into the call center because they can resolve the issue themselves. And as I said before, I think self-service, particularly from a younger demographic perspective, you know, is an engagement, our first engagement, that a lot of people are starting to prefer more. So I think the home warranty provider or extended warranty provider, you know, and or the home appliance OEM who has their own service ecosystem for devices in the warranty are looking more and more in that technology as to be a component of what they're delivering for their service. And, you know, I think we're seeing more and more of it as a preference from the end customers as well to have this sort of solution and technology available where they can troubleshoot their own problems. So the sort of net of analysis in this particular use case, and this includes, you know, reduced truck rolls. It includes call deflection, okay? It includes first time completes over a call that ultimately reduces the aggregate amount of calls and actually truck rolls itself. And parts prediction, where you can provide a much more deterministic view of what parts are needed, okay? And with that, you know, are producing truck rolls that are going to be much more efficient, not needing a repeat truck roll because the technician has the right parts of the job. So collectively, this led to, you know, in this particular customer, you know, led to a roughly, you know, 10 million savings in their warranty costs by introducing these technology. And I think the important point, you know, of this type of technology, okay? You're not just reducing costs, but you're doing it by enabling better solutions, quicker resolutions to actually fix customers' problems more quickly, okay? Be it over the phone, be it over self-service, be it by having a truck roll that, you know, works and allows it to be fixed the first time. In addition to reducing costs, all of these you know, increase the customer satisfaction and your customer experience numbers as well. So with that, Tim, we'll
I think it's Q&A time now. And so if any of you folks out there want to submit a question, please go right ahead. We've got a couple we can actually tackle right now if you're ready, Tom.
Yeah.
I think the first question here is, when you refer to home appliances, what else might that include? For example, white goods, water heaters, HVAC equipment.
Yeah.
What's in there? What's in there that we can help with?
In terms of what we built model for, include major home appliances, okay, sometimes called the SOHAM, AM6, okay, but plus other residential home appliance equipment as well, including residential HVACs and water heaters as well.
Gotcha. Now then, I don't know if we have any commercial manufacturers joining us today, but that's certainly another question that often comes up is equally, can this apply for commercial building HVACs?
Yeah, good question. We obviously we kind of focus on the sort of home appliance market today, and the OEMs and the ecosystems of home warranty and extended warranty companies who provide service there. But we do have models and solutions for commercial HVAC as well. Okay. And we do have customers in that market vertical as well. Some slightly different kind of things that come into play there, particularly around, preventive maintenance. Okay. That's often a kind of a factor in that industry as well, but we do have tools there. So yes, we have, solutions and customers in the commercial HVAC space as well, but, talk most today about kind of the home appliance space.
Gotcha. All right, next question. This, I think, refers back to some of the stuff that Ajay covered earlier. The question is, would we need to hire a data science team to develop some of the machine learning models that were described here?
No, and this is sort of, right, I think, a real benefit to sort of end customers is that, in the home appliance sphere, okay, we have already developed models, okay, for all of the major home appliance vendors, okay, and their particular equipment types, from laundry to cookers to washers and so on, okay, and dryers. So this is all pre-packaged and available from us, okay? So if you're a home warranty or extended warranty company here, and you obviously have, an install base, okay, of home appliance equipment from, a range of different vendors, okay? That's, different model types, okay? Different ages, okay? You're gonna have an install base of, quite a diversity of equipment. We'll be available, using the Bruvity Home Appliance Suite, we'll be able to make available to you immediately models that are ML models that are built for all of the major home appliance vendors, okay? And all of their equipment types. So you'll be able to, immediately use this solution, okay, for equipment and product that's in your service install base, okay, without having to go through a data science exercise and have a data science organization to do that for you, because we've already built those models and really have a lot of, which makes the models even better, have a lot of sectorial and vertical expertise in the home appliance space. So anyone can use this, almost off the shelf if you like, because we've pre-built all of these models using the technology that Ajay was talking about.
Gotcha. So a lot of the heavy lifting's been done already then.
All the heavy lifting's been done, but the net is that, you can turn this on almost immediately, okay? And derive some of the benefits from both a, cost, customer experience, first-time fix perspective using this technology and integrate it into your service workflow.
Good. Another question coming in. Yeah, is there an API to integrate capabilities with other software? I mean, I know we get asked occasionally, about CRM platforms and the like.
Yeah.
What about other sort of web services, apps, for example?
So sometimes we integrate. The typical scenario where we deploy, okay, is we'll integrate from a service workflow with the CRM that may be in use by the end customer, okay? So we would have done, CRM integrations with all of the major vendors in that space, okay? So we're very often integrated in with those CRMs and some other parts of that ecosystem. So there is an API that we can integrate with, okay? And, when I was talking about the kind of virtual assistant before, that's often integrated with a CRM that would, populate the information that we were looking at for around the end customer, the equipment they have in service, et cetera, et cetera. Then obviously record it, be part of the workflow to the service technician and so on, okay? So we do integrate with typically with CRMs and some other software and have an API in customers we go into. But I'd also like to point out that this particular product is available to be used initially. It's a cloud-based solution. Okay. You can use that virtual assistant tool that I demonstrated, exactly how I gave that demonstration, off the shelf, for home appliance equipment vendors, their model types that you may have in your service install base. So you can start this, to be used almost immediately. But sometimes there's an integration that occurs with the CRM and maybe some other entities. But we typically have integrations already in place with most of the CRMs we find in our end customer base. Gotcha.
Well, now we're at the top of the hour now. I think probably we should pull this thing to a close. I'm pretty sure that we're going to make the recording available down the road. So if anybody wanted to share this with their team members,
just one more question that I know.
Yeah, Tom.
That came in there. That someone was asking, beyond customer service triads, and finally, are there any other tools that we make available to AI tools that we make available to home warranty, extended warranty vendors? So we've done some work, and this is available to other customers as well with some of our customers, that makes an assessment of whether the particular piece of equipment in service, okay, is actually worth sending out someone to fix, or if there's a better option where you may make that end customer an offer for a new piece of equipment, okay, rather than actually trying to triage the equipment. So something adjacent to which we do, okay, but not directly related to, not, exactly the customer service triage that we're and resolution that we're doing, with the customer. So there's some adjacent things we do from an AI point of view that are directly complementary to our other tools from a customer service perspective.
So that might be, say, in the warranty, sector, for example, or
a couple of customers that they wanted to make an intelligent assessment, okay, and that include what our assessment of the problem was and troubleshooting it, okay. Was it make an assessment? Is this a better option to try and fix this? Or should you make the end customer some sort of offer for new equipment? Okay.
All right. And anything else to add at this point, Tom?
Not me. I think we're at the top of the hour, right?
Well, thanks, everyone, for your participation here. We really appreciate it. As I said, we'll make this recording available. And I think we're going to draw this to a close. Rich, I see maybe a question coming in. Let me just check. I think we're good to go here. So thanks again. We'll be hosting more of these in the future, so stay tuned for those.
Okay, thank you.